Math 5130, for those of you that aren't digging R and want to see all this demonstrated in StatCrunch, this is for you. So let's load our file, browse. I think I called it data, body data. So let's import it, let's upload it, and there we go. All right, so sample size 300, again, it's kind of goofy, but just scroll down and you can see our sample size. If I want the mean and standard deviation, again, it's very simple. Just go to summary stats column and just get the pulse and select everything that we want. I think we need the min max. Looks like we need Q1, Q3. This is kind of getting redundant, I think, a little bit, because I've demonstrated this so many times. So just move all this information and type it in. Try to not make any typos like I'm notorious for doing. Next thing, outliers. So we're going to hop to a box plot. Let's do pulse. And we can see we have an outlier. The outlier is a pulse of 36, which is seems to me to be a low outlier. I'm not a medical doctor, so. But I will tell you kind of an interesting story. I was at a conference one time in San Antonio, and we were right on the Riverwalk, and I was with a couple of my colleagues, and we were bored with whoever was speaking at the conference, and so we got in a competition to see who could bring their pulse rate down the lowest. So we went there, we sat there in the conference. It's kind of goofy to tell this, but we sat there in the conference and we went into like this Zen factor, all three of us. And one of my colleagues, I said she's kind of high strung. She couldn't get hers much below like 80, I think. But the other colleague and I, we got ours down into like the high 40s. So anyway, I have no idea why I shared that with you. Going to the categorical, so stat, table, frequency. Let's take a look at age and frequency and relative frequency. So you can see we have the counts, and we have the relative frequencies, 37.7%, which is reported right there. Histogram again, hesitate to do this, but it's going to give you a little different histogram than R. That's why you would copy and paste this from StatCrunch, and you would definitely need to change this to where it says you're using StatCrunch and cite it like I've done in previous videos. ANOVAs are really easy to run. Imagine that. We go to ANOVA, we go to a one-way, and I have values in a single column. So I have pulse, my factors, in other words, my categorical independent variable is age. I want to compute Tukey highly significant differences at a 0.95 just in case. And that's it. So I like StatCrunch for this reason. It gives the descriptives. It gives me the means across each level and the standard deviations. And then, of course, the degrees of freedom, 2,297. The test statistic is right there, and the p-value, which I've reported right over here. To get the effect size for ANOVA, we would take 1123, 9.9627 divided by the total, which is 43979.667. That's one thing I like about StatCrunch over R, is it does give you the total sum of squares, where for R you have to add these two numbers to get the total sum of squares. So getting into the mean, again, that's all reported right up here. In other words, the mean of pulse across each age group. You can see that using 2-key HSD, we get the same p-value, and we get the same, let's see, point, actually we do get a different, interesting. So the difference is, I just wonder if I didn't type it incorrectly. This is negative 0.18. Oh, yeah, I did. So 0.18, so that should be 0.18. Oops. So corrected that from the previous video. I say those things should match up. So run from negative 8 to 0.24. Make sure I didn't make any other silly 3.99. All right, so p-values reported here. Results from a Shapiro-Wilk test. I demonstrated this previously. Let's see, I need homogeneity. So I want to do pulse, and I want to do Levine's test. Interesting. Oh, Levine. Goodness. Over age. There we go. You can't test equal variances just for a single variable. Duh. Gosh. So our test statistic 0.54, p-value 0.58. You will notice that the default for Levine's in StatCrunch as compared to R is the mean, not the median. And then to get Shapiro, it's kind of weird, but we have to do it this way. Go one sample with data, choose pulse, and then come down to Shapiro-Wilk normality test. Doesn't matter what we put there because we're not really concerned about the output. And you can see that Shapiro-Wilk has a test statistic of 0.99, p-value statistically significant at the 0.05 level. So sorry about the typo. I hope that doesn't cause any problems. There's no magical math out there that changes negative 0.8 into negative 0.37 or whatever that was previously. Just a bonehead mistake. And you know what? It's something you do really have to be careful with because you're typing so many numbers, and rounding, and you're trying to pay attention to detail, and it's just possible. So that's why it's a really good idea when the stakes are high to always double check. And when the stakes are really high, I like to have an editor. I don't have to go to like the New York Times and hire an editor or anything, but just have a friend of mine just look at the outputs and just compare the values from the output with what I have typed in, because you can make mistakes really easily. It's really easy to transpose, like instead of 0.18 be 0.81 or something like that. But it's just the nature of the beast. All right, take care.